Hello dear students, welcome back again to calculate to solve some of the examples we left about this topic. Previous lesson we studied question 1 chapter 3's example, but some of the questions we left. Inshallah, this video I'm gonna explain all the example that was left. Be with me step by step. Let me start. Guys, question 2. We have a 2.8 rectangular air matrix. What is the meaning of air matrix? Maybe now you'll be confused. What's the meaning of air matrix? Guys, air matrix, and this is the shape of the air matrix. Air matrix is the thing that the object that they are using, for example, for the child, for the kids, when they don't know even how to swim. They are using this air matrix to avoid themselves for sinking or goes underwater. So they are using this air matrix to staying on the surface of the air matrix when they don't know how to swim. So this air matrix shape. So the mass of the air matrix is equal to 2.8 kilogram. And 2 meter long, the long L 2 meter long, and 0.5 meter wide, W 0.5 or 0.500, same, but just I make it easy. I wrote 0.5 and 0.1 thick. Thick, it means H, 0.1 thick. So all by meter. Okay, so the question said, what mass can it support in water before sinking? What mass can it support in water before sinking? What that mean? That mean, guys, building plate is important to understand. As we know that the air matrix is on the surface, or sometimes we have some types of the air matrix that are going inside the water. When the air matrix goes or moves under the water, of course, some waters goes inside the air matrix, so the mass of the air matrix become increased or become heavy. But I forget something. Wait, let me tell you something. Before the air matrix goes under the water, we have the original mass of the air matrix is 2.8. This is the original mass of air matrix 2.8. But during when the air matrix goes under the water, some of the water goes inside the air matrix. So the mass of the air matrix become large, because they receive some mass. This mass is the mass of the air matrix before it goes under the water. This is the mass of the general air matrix. This general mass or the real mass of air matrix. But because the air matrix goes under the water or the surface, some of the water goes on it. So the mass of it become heavy. So now, what mass can support in water? Yani find the mass of the water, find the mass of the air matrix. The mass of the air matrix, or we can say find the mass of the water that it goes inside the air matrix. Find this mass extra when it goes inside air matrix. And as we know that the first has a mass, it's 2.8 kilogram without putting this air matrix under the water. After a while, when we put the air matrix under the water or inside the water, look, a few waters goes inside the air matrix. Of course, they must become heavy. We want to find this extra mass that it goes inside the air matrix, the mass of the water. As we know that, dear students, we studied this rule and we said all time buoyant force that is equal to the weight Fg. All time both are equal. And we said Fg is equal to mg according to the Newton's law. So FB all time equal to FG because both are equal, and for both is equal to mg, so I can write mg for both. FG for mg and FB for mg. So this mg for both because both and both equal to mg. And guys, this Fg is equal to mg. This is the weight of the object. I want to find the weight of this object. So I can mention like m naught, the mass of the object, or m naught, the mass of the object. So this mass, I want to find this mass. This is the mass extra of the water. And we have another rule. And we studied the density equal to mass over volume. Find the mass in here. Mass is equal to rho v. So just replace this mass instead in here, write rho v. So become rho v and bring down g. But do not touch this m naught because I want to find this m naught, the mass of the water, the extra mass. So bring it down, m naught g. Guys, as we know that gg both can be cancelled because both have same value, both are acceleration, both the value is 9.81, become cancelled. So only m naught is left, which is equal to rho v. Okay, density, this density of the water, and the density of the water is 1000 all time, times volume is left. Guys, volume is the multiplying of three quantity, long, wide, height, LWH. So 1000 times L is 2 meter times W 0.5 times thick is 0.1. Multiply all. The mass is become 100 kilogram. The answer of multiplying. But guys, look, this is not the last answer. Let me tell you why. Because the question said find the extra mass. The mass can support, what mass can support in water? So find the mass of the water that goes inside the air matrix. This mass now already in here we found it is equal to 100 kilogram. This mass is the resulting of plussing two mass. First, the mass of the water plus mass of the air matrix. Because we know that because of these two mass, the answer is become 100. Because we have the mass of the origin is 2.8. But after, when the air matrix goes under the water, some of the water goes on it. That's why we have a mass of the water too. So that's why the answer has become 100. But now only I need to find the extra mass. I want to find the mass of this water only, not both. So this is both. No, I need only just to find the mass of the water only. How we can find the mass of the water? We know it's equal to 100. The mass is equal to 100. So 100 minus the original mass of the air matter is 2.8. So multiply by 2.8. So the answer is become 97.2 kilogram. So this mass, finally, that one is the extra mass. The mass of the water that goes inside the air matrix. Look, you can't understand like that. Compare both mass together. Compare both mass. First, it was 2.8 kilogram without putting the air matrix under the water. 2.8. After, when the air matrix goes under the water, the mass 97.2. This is the mass of the water that goes on it. So 97.2 mass of the water goes inside the air matrix, so to become 100. So this 100 is a total mass after the water goes on it. Total mass is the mass of the water and the mass of the air matrix. but that one only the mass of the extra waters, only the mass of the water, and that was only the mass of the air matrix. So that one is mass of the air matrix only, and this is the mass of the water only. You can plus together to get a total mass. So the last answer is 97.2 because I just only want to find the mass of the extra water is 97.2. Guys, question 3. We have another example. A ferry boat is 4 meter wide, W equal to 4 meter, and 6 meter long, L 6 meter. When a truck pulls on it, the boat sinks. Guys, look. In that case, when a truck pulls on it, for example, we have any object. For example, we have this object. If the object sinks, goes under the water, of course, we know that it takes some distance under the water. So this distance is called h, depth. So the h equal to 4 centimeter. What is the weight of the waters? Sorry, what's the weight of the truck? Guys, same rule. We know that if Fg or Fv equal to Fg, same thing, both are equal. The question says find the weight, and we know that is equal to mg. Okay, so Fg equal, instead of the mass, immediately we can make it rho Vg. According to the rule, according to the rule density, we said that mass over volume. Find mass again. Mass is become rho V. So put the mass in here is become rho V. Okay. Density of the water all time is 1000 times the volume. Again multiply both. LWH times G is acceleration 9.81. So 1000 times L it's 6 meter times W 4 meter times guys, because the h it comes by centimeter, so compare this distance with the other one. Look, they are not same unit. That one both is meter, but that one is centimeter, different. So you have to convert this centimeter like the other one to make it meter. How we can make centimeter to meter? Multiply by 10 power negative 2. So the 4 is become 4 times 10 power negative 2 and bring down 9.81. So just calculate. We use calculator. So the answer has become 9.4. The last answer, Fg, 9.4 times 10 power 3 Newton. 9.4 times 10 power 3 meter. Last question, but it's actually it's two part. Guys, this question is about balloon. We have a balloon. This is the shape of the balloon. Imagine this is a balloon. This is balloon, and the mass of this balloon is equal to 0.0100 kilogram. The mass of the balloon, let me write it later, not now. Our empty rubber balloon has a mass 0.120 kilogram, and the balloon is filled with the helium, and the density of the balloon is equal to this. And the filled balloon has a radius. Okay. What is the magnitude of the buoyant force? Find buoyant force, and again Fb equal to Fg, same rule, and again equal to mg, and again same thing is become rho Vg. Okay, bring down this in here, rho Vg. Guys, let me tell you important point. Now, because we know that the balance goes upwards, not like the other lesson, the other questions, an object goes under the water. No. Now the balance goes upwards, so upward, of course, we have air. So the balance goes upwards on the air. So in that case, we have to write the density of the air, not the density of the water. So look, even it's written, for the density of the air. Look, see table, this one. You have to write the density of the air because the balance goes upward. Find or write the density of the air. Density of the air is 1.29 times volume. Students, because the shape of the balloon is like a sphere, like egg. So we have in math, you studied, I think, the volume of the sphere or the volume of this balloon is equal to 4/3 pi r power 3. Why, mister, we have to use this rule volume? Because the shape is different. The shape is balloon, like a circle, like a sphere. We have to use this rule for sphere. So 4 instead of the volume, write this rule. 4/3 pi r power 3 times, bring it down the g in here. Okay, look, 1.29 times 4/3 times 3.14 times radius at 0.5, because it's power 3, so right inside the bracket 0.5 power 3, be careful, times, and we know g is 9.81. So multiply all together, the answer is 6.63 Newton, the value of the buoyant force, FB. Students, same thing, same rule, only in here there's some things new. Sorry. The density, we have to write density of the air, not water, because we said the balloon is on water, not inside the water. Sorry, the balloon goes upward in air, not under the water. So we have to write the density of the air because the balloon is in the air, 1.29 times V. We have 4/3 pi r power 3 because the balloon shape is like a sphere, so we have to add this rule, 4/3 pi r power 3 times g. Okay. Bring down all the numbers and the pi is become 3.14. The radius is 0.5 and make it power 3 times g is 9.81. Multiply all and it's become 6.63. The part B question said, what is the magnitude of the net force? Guys, be careful. The question said net force. If you remember, we studied the net force rule is equal to what? Equal to FB minus FG, buoyant force minus FG. How can we find Fnet? Actually, guys, FB now we found it in the previous part. It was 6.63 Newton. Look, we found it. If buoyant force is equal to 6.63, but you have another problem. We don't have FG. So we can find Fg easily by this rule. Fg equal to mg. And this mass is the mass of the balloon, guys. We have two mass, we have to plus it. First, mass of the balloon and plus mass helium. Bring it down, this gene here. Why, Mr. Two mass? Guys, have a look. Because this balloon, and as we know that the balloon inside the balloon is filled totally by the helium gas, right? So the helium gas has a mass and the balloon too has a mass, so there's two different mass, the mass of the balloon as the mass of the helium, because the mass of the helium, we have a mass of the helium, and even the balloon too has a mass, so there's two different mass. That's why. Okay, so yeah, the mass of the balloon, the question, it was written, the mass of the balloon 0.0120 kilogram plus, but there is no mass of the helium. But we have another rule to find the mass of the helium. According to the rule density, density equal to mass of the volume. Find the mass of the helium. Mass of the helium equal to rho v. And we know the density of the helium is 1.29 because this mass helium, so you have to write the density of the helium times the volume. Guys, if you remember in the previous section, the previous example, we wrote this rule. Instead of the volume, we wrote the volume of the sphere. And here, same thing. But Mr. Maybe you have example, but Mr. We have to find the mass of the helium. Why you have to write the volume of the sphere? Guys, because the helium inside the balloon, it take the shape of this balloon. Look, the helium, it take the shape of this balloon. That's why we have to write the even rule of the balloon. Same volume, 4/3 pi r power 3. Okay, 1.29 times 4/3. Let me make it place. Sorry, wait a minute. Okay. Mass equal to rho v equal, and we say the density of the helium to 1.29 times 4/3 pi r power 3. 1.29 times 4/3 times 3.41, this pi times the r, this r, same thing, 0.5 power 3. So find this mass, the mass of the helium, the mass of this helium, multiply by the calculator, the answer is become 0.094 kilogram. The answer of this mass 0.094 kilogram. So put this mass of the helium in here. Look, 0.094 kilogram. 0.094 kilogram. Put it in here. So again, use calculator. First, because in here there is no, so first plus this at the end, multiply by g, 9.81. I mean, first 0.0120 plus 0.094 plus this, and at the end multiply by 9.81 because the accelerations were left. Multiply all together. The answer has become 1.04. The answer Fg is become 1.04 Newton. So put this Fg in here, 1.04 Newton. So minus it together, the last answer become 5.59 Newton, the net force. So guys, first, because we don't have Fg, we found Fg by this rule. We plus both mass of the balloon we have, and mass of the helium we don't have. We have to find it, which is equal to 0.094, and this is the mass of the balloon. At the end, plus this and multiply the result by 9.81. The answer is 1.04. How we can find the mass of the helium? According to this rule. According to this rule, let me write it again. Maybe it's not confused at all because of we mix it. I mean the handwriting. Maybe you don't understand well. Let me decorate for you step by step. Look, Baba. There is no FG. We don't have FG. Find FG by this rule. FG equal to mg. So the mg is become mass of the balloon plus mass of the helium. But let me make it nice. Okay, and here write a good mg. So the mass number 1 plus mass number 2 multiply over by g. So this mass is balloon, and that balloon, and this mass is the mass of the helium. Okay, the mass of the balloon, it was 0.0120 plus the mass of the helium. In here we don't have it, right? I bring down the g. We don't have the mass of the helium. So now how we can find the mass of the helium? According to this rule, the density, it was mass over volume. Okay, so we want to find now mass of the helium. How? The mass of the helium equal to density times V. The density of the helium is equal to 1.29 and times the volume of the, it was 4 over 3 pi r power 3. So 1.29 times 4 over 3 times the pi is 3.14 times, and the radius is 0.5. The radius it was 0.5 power 3. The mass, multiply the mass, the answer of this mass has become, mass of the helium becomes 0.094. The mass becomes 0.094. The mass becomes 0.094. So bring down this again, plus 0.094. We found it now, and at the end, when you plus it, multiply, do not forget, by the acceleration. So the last answer of the FG has become 1.04. 1.04. Okay, so we found FG immediately in here, and the value of FB, it was 6.63 minus, and we found FG is 1.04. The answer is 5.59 Newton, the value of the net force. Guys, this lesson is finished. We solved the example that was left. I hope to get the benefit for all my video. If there's any question, you can write down in the comments. Thank you for all. Have a nice day.